Okay. In the last lecture, we introduced the requirement about the subgrade aggregates that we want to do the LA abbreviation loss test, and we also want to do the microdevil test, and possibly we want to make the sulfate sunless test to identify the freeze thaw effect. And also we have several minutes in the last lecture to introduce the way to improve the quality of the aggregates. And one way is like we want to apply some treatments to the aggregates, like we can use the bitumen to improve the granular cores, and also we can apply the cement. There will be more methods for us to improve the quality of the aggregates and the soils, which will be covered by the materials in the second half of the lecture today. At the first half of the lecture, we will continue the introduction about the materials that we can use for the subgrade or the subbase layers for the pavement design. In addition to the bond, the bond-based materials, we also have the reclaimed materials. This would be some recycled materials from the old pavement structure. The commonly applied materials is called the reclaimed asphalt pavement material, and this one will use the old asphalt layers, the asphalt materials from the pavement structure. Usually, we will for us to get this recycled material, we will pulverize the older asphalt pavement up to 50%, pulverize them, and then mix them with the new materials. Usually we will add the less than 50% of the reclaimed asphalt pavement, and it will be applied for us to replace some mineral aggregates in the new material. So this will help us to reduce the cost of the pavement or the aggregates we're going to use for the base and subbase layers. We can also use some steel slag. This would be some industrial waste material. Of course, it's also applied because we want to reduce the cost of the pavement construction. And we also can use some reclaimed glass or ceramics. Those are also widely applied for the our maintenance and the reconstruction of the pavement structure. But there will be some problems for us to implement the steel slags. They are usually for this, as they are steels, they are this kind of materials is very sensitive to the water contents, and it will be very sensitive when the moisture contents increase, and the volume will be larger, and this will create some deformation about the pavement structure. And there will also exist some chemical reactions between this kind of steel slags and the waters, so it will make the pavement structure unstable. This figure actually shows the distribution about the grain size for different type of the materials, like especially for the reclaimed bituminous materials. This actually the RAP reclaimed asphalt pavement material is the same to reclaimed bituminous material. So those are the same thing. And usually for those kind of the materials, they will fall under the limitation of the granular A material. They will usually be treated as the granular A material in the pavement design. To utilize this kind of reclaimed material, what we do is like we will first polarize the asphalt concrete from the existing pavement structure, especially for those pavement which are not able to provide a smooth service or provide a reliable service for the traffic load. And then we want to polarize the surface or the asphalt materials and mix them with the new granular aggregates, and then do some compaction. This will make them be another layer of the pavement structure. You can see the figure about the constructions with the reclaimed bituminous materials. And this figure actually shows the how it looks like when we apply the reclaimed bituminous materials. And this is actually in the road after 10 years with the reclaimed bituminous materials. And you will see that there will be a lot of cracks along the, including both longitudinal and transverse cracking along the road. It means that the pavement won't last for very long time if we try to utilize the reclaimed bituminous materials. Of course, if we want to control the budget, it's in a good way. But if we consider the long-term design, then you have to carefully select the amount of the reclaimed bituminous materials in the pavement design. This is another picture to show the potential distress caused by the reclaimed bituminous materials. So you will observe the longitudinal cracking. This is usually the cracking formed at the joint of the PCC slabs or the some semi-rigid slabs behind the pavement structure. And also you will observe a lot of rottings, which will cause the crackings at the edges of the road. And so those are some typical issues of the reclaimed materials. We also have, in the literature, there are also some research about the impact of the RAP contents with respect to the stiffness of the materials. What do we find that basically, generally, if we increase the amount of the reclaimed materials, the CBR value will be reduced. This actually applies for most of the materials, and this indicates that the stiffness of the road will be smaller, and you can easily create some deformations on the road. But if we go to check the resilient resilient modulus for the two figures at the bottom of this page, you can see that the amount of the reclaimed materials, which will be represented as in these two figures, you can see 0%, 25%, 50%, and 75%. They did not increase the. They did not affect the MR values a lot, even though they can increase the increase or decrease the MR value a little bit, but this changes is marginal. So it means that the resilient modulus of the materials will keep the same, and the different amount of the reclaimed materials. So with that consideration, we have to carefully select the amount of the RAP contents. Another thing in the literature we find that is the increasing the RAP contents, the accumulative deformation will increase dramatically, and the figure here actually shows the increase about the accumulative strain, and this indicates that the deformation of the pavement structure will be larger if we increase the RAP contents, and this larger deformation will create the rotting distress of the pavement structure, and this is not a good sign for the performance of the pavement. And with all this analysis, in the real-world implementation about the pavement design with the reclaimed materials, we want the RAP contents to be less than 50%. And if we want to keep the optimal performance, you should maintain the contents around 20 to 30% so that we have an acceptable performance of the aggregates, as well as we can control the budget of the pavement structure. So that's the reclaimed materials. The other type of the materials is called the roller compacted concrete. This one will use the zero slumped concrete with a low water cement ratio. It looks like quite similar to the aggregates, but if you check look in close to those aggregates, it will be very different to the regular particles of the soil. And this type of the material will have low fatigue resistance. So it will also have some, well, even though the cost is low, you also have some problems to create the fatigue cracking. And if you apply this type of the material in the flexible pavement, you will create the semi-rigid granule base, as not the flexible granule base is instead is in the semi-rigid granule base, or you will create a composite pavement structure. And this type of the structure can easily create the longitudinal cracking or transverse cracking, which would be the cracking from the created at the joints. This type of the materials is also applied in Ontario at a lot of Ontario roads, but the performance of the pavement with these materials is not that good. We will observe a lot of cracks along the pavement structure. So for nowadays, we will rarely apply this type of the materials in the pavement structure. So these two figures shows the utilization of the roller compacted concrete, and we also can see how it's going to be utilized. Basically, will be this type of the materials will be utilized as the regular aggregates on the road, and you can utilize them to do the pavement quickly, but by checking the surface of the pavement structure, there will be a lot of cracks. The last one that I'm want to introduce is called the lean concrete materials. It's also called the ECONOCRETE base and subbase materials. It's actually mixed some cement with the aggregates. The cement contents will be around 133 to 175 kilogram per cubic meter, and this is approximately 7% of the weight for the pavement for the aggregate materials, and the slumps around 25 to 75 millimeters, and the air contents is 3 to 9%. And also have some compressions applied with the strength of 5 to 10 megapascal. So this type of the materials will have very high strength and high stiffness, and they don't need a lot of materials to construct the pavement structure. So the layers with these materials would be very thin, and also it's now erodible, so it's not very good to support the pavement structure for a long time, and it will have the improved load transfer, so you will be able to protect the pavement structure at the bottom. But usually this one is only applied for the rigid pavement. For the flexible pavement, we will think about the alternative materials. The last one, this will be the actual last one. It's called the open grade drainage layer. We actually, in the future slides, we will have more detailed instruction about the open grade drainage layer and how to design them. It's also called the asphalt treated permeable base. This is usually it's applied as the drainage layer to remove the water from the pavement structure. And This layer is usually placed behind the asphalt layer, such as the dense graded hot mix asphalt, the stone mix asphalt, or the PCC slabs. And it will be used as the base layer, and these materials will usually have only around 1.8% of the contain some 1.8% of the asphalt materials. And there's another one quite similar to that. This is called the open graded friction course. But the standard for the OGFC is much higher than the asphalt treated permeable base. We will have more discussions about both materials when we introduce the drainage system of the pavement structure. Usually for the normal asphalt concrete, the asphalt content is 4 to 5% with the air weight of 4%. But for the open grade friction course, it has much higher percentage of the air voids, like it's set as 15%. With that, it will be very easy to remove the water, to drain the water from the pavement structure. So I think that's all about the highway subgrade structure. In these 3 lectures, we introduced the properties of the materials applied for the highway subgrade layers. They also could be applied for the base and the subbase layers. We also introduced the way for us to improve the actually in this lecture we introduced the way to utilize some reclaimed recycled materials or to utilize some improved materials to gain better mobility for get better property of the subgrade layer and base layers. So this would be some very general treatment about the aggregates for the base and subbase layers. And in the real world implementation, there will be some more advanced method for us to further improve the properties of the soil in the field. That will be the contents we're going to cover in the next lecture. In the next note, do you have any questions so far? Okay, if there's no question, I will go to the next slides about the improvement for the soils which will be applied for the pavement design. Okay, so in this notes, we're going to introduce the soil improvement and the stabilization. So we are basically here, we're going to introduce the some fundamental methods, including the physical method and the chemical method applied to change the property of the soil so that it can satisfy the requirement of the base and subbase layer or the subgrade layer. So at first, basically the soil stabilization is in the process of blending or mixing the materials within the soil to improve certain properties of the soil. For example, we want to achieve the desired gradation. That would be the grain size distribution of the aggregates. We want to mix the some commercially available additives and change the gradation, the texture or plasticity of the materials, and using these additives as the binder for the cementations of the soil so that we can get a higher strength or the stiffness of the material. So this kind of stabilization process will change the permanent physical and chemical alternations of the soil and also the aggregates, so that the engineering properties like the loading bearing capacities could be larger, the cohesions and the friction angles could also be larger to support more frequent more frequent traffic load and also the larger traffic load on the road. And the basically the objective of the soil stabilization is increase the soil strength, reduce the compressibility, and reduce the moisture susceptibility for the fine-grained soils. And also we want to improve the property of the borderline materials. If you remember the first heave effect, there will be some materials forcing the borderline. We want to move them to the regions with as the suitable materials. Also, we want to do the dust control, the moisture control, and also we want to do the maintenance to improve the road performance of the older road, and to develop some superior base layers so that we can. We don't need to worry about the bottom layers of the pavement structure, and for the reconstruction, we just need to work on the surface layers, and this will reduce the cost of the pavement construction a lot. And for the stabilization, there will be some basic principles. First, you need to evaluate the property of the given soil. You should know what's the weakness of the given soil, and identify the which part you want to improve, and then you're going to need to choose the appropriate method for the soil stabilization. We want to control the budget. We want the method to be very effective, and also you need to design the stabilized soil mix for certain goals. Like we want to specify the processed or stabilized soil to achieve certain stability and durability in the future. So that's the basic principle we have to consider for the soil stabilization. And basically there will be several types of the soil stabilization. The first one is called the surface stabilization, and this one will only affect the property of the soil within the depth of 1 meter, and it won't affect the it won't change anything about the soils behind 1 meter. And the other one is called the subsurface stabilization, or we call it the ground improvement. And this one can help us to improve the property of the soil with higher depths. So we can use some geotechnical process to improve the engineering property of the soil, such as the density, the shear strength, the cohesion, and the friction angles. And with that, we can reduce the compressibility, the settlement, and the permeability. And by this improved properties, the soil will be utilized as the base subbase layer or subgrade layer, and it can support the pavement structure with a longer time and with a stable performance. And those would be two typical soil stabilization. And for the selections of the method that we're going to use for the stabilization, usually we need to consider 4 factors. The first one is the budget. Of course, we want to make sure that the budget is under the reasonable range. If it's too high, probably it will be, instead of doing stabilization, we probably want to replace them with new materials. And the second one is the materials we want to stabilize, whether the material is available for us to conduct the stabilization. And the third one is the availability of the stabilizing agent, whether we have the tools or whether we have the some additives which can be applied to improve or stabilize the soil. And of course, we want to have some engineers which will have the experience to do the stabilization. And generally, there are 2 methods for us to conduct the stabilization. The first one, that will be the mechanical method and the admixture method. I will introduce both of them in the lecture today. First, for the mechanical method, There will be actually 5 common methods applied for the stabilization, including the compaction, adding the gravels, the blending, the geosynthetic, and the lightweight fill. The compaction is the one that we introduced in the previous lectures. Like we will just add some compaction force to the soil, and with this, usually this method is applied for the unsaturated soil. It's able to improve the density, strength, and stiffness of the soil. The second one is about the adding more gravel materials to the soil. This is usually applied for the silt or clay materials. But you have to remember that if you do this method, it will actually reduce the adding more gravel will reduce the dynamic stress level. The next one, which is actually a very good method called blending, and it will be generally applied for the soil with moderate plastic. And with this method, you can actually control the gradation of the soil and achieve to the target gradation so that you can gain the property you want. So with that, you are able to improve the gradation, reduce the plasticity, and reduce the breakage. But this one is very costly, and usually it's really hard for us to mix those materials or blend those materials together to achieve the target gradation. So it's not quite efficient. The first one is called the geosynthetics method. It's also applied for the silts and clays. This method can increase the strength and minimize the disturbance and consolidation for the soils and the different layers. And of course, this method is very fast. You just need to apply some geotextures along the pavement layers and add different layers on above and below the geotextures. It can provide a long-term separations about different pavement layers. This will have some benefit and also have some drawback for the pavement structure. And the last one is called the lightweight fill. This one it's only applied for the very weak silts, clay, and peat. With this one, we will actually need to consider using new materials to replace the original soil. And by adding this kind of fills, we can provide thermal barriers so that the first heat effect will not penetrate through through that barrier. As this field is also very thin, so we can finish the project very fast. But also this will also reduce the dynamic stress levels for the soil. So those are the general mechanical stabilization methods. In the mechanical methods, we don't have any chemical reactions or change the composition of the materials. It's still the material. What we do is that we will just change at most time we will just change the density or the gradations of the material. And with the mechanical method, we will only change the physical properties like the densities, and also we will apply some reinforcement along the pavement, inside the soil. Usually, the most commonly applied method for the most commonly applied mechanical method is geosynthetic methods. They will place the geotextiles or the geogrids or the geomembranes on top of the soil, and then it will be performed as the barrier on the additional layer to support the pavement structure. This would be some typical geosynthetics applied in the pavement structure. It could be placed for between the subgrade and the subbase layer. It can also be placed between the subbase layer and also the asphalt layers. And there will be some benefits for us to utilize the geosynthetics in the pavement structure. You can see that you can compare the distributions of the traffic load under the boundaries between the base and subbase space and subgrade layer. And for the flexible pavement, if you don't apply any reinforcement from the geotextile, then you will see that the distribution of the distribution of the strength is more concentrated, and for the point behind, directly behind the tile, the stress is very high, and this will potentially cause a very high deformation at the subgrade layer, and it will potentially result in the rotting or the fatigue cracking, and the other type of the bottom up cracking, all this type of the distresses to the pavement structure. But if you apply some geosynthetic reinforcement, like apply some geogrease or apply some geotextiles between the subgrade or the subgrade layer and the base layer, then the load transferred from the base layer to the subgrade layer will also be supported by this geogrease, and in that sense, the distributions of the load at the boundaries of the base and subgrade layer will not be that concentrated. You will actually distribute it evenly along the boundary, and with that, it can protect the subgrade layer, and it will generate less deformations, which will then benefit to the pavement structure. So that's one benefit for us to apply the geosynthetic reinforcement to the pavement structure. And it can also help us to prevent the shear force. These three figures actually shows that how the shear stress is actually distributed along the pavement structure, actually between the base layer and the subgrade layer. With the geosynthetic reinforcement, they are able to transfer the shear force to the other regions and also reflect it back to the base layer. And with this kind of process, it's able to increase the bearing capacity of the subgrade layer. And of course, if there's any distress applied, I mean, if the pavement structure is not good enough and there's some distress there, they can also provide some membrane support. With that, you will see that the significant distress at the surface of the pavement structure won't be propagated to the subbase layers a lot. Instead, the subbase layer is still have an acceptable deformation, so that in the future, if you want to conduct any reconstruction, you don't need to work on the subgrade layer. Instead, you just need to replace or repair the surface layer, and this will reduce the cost of the construction a lot. So those would be the benefit of introducing the geosynthetics in the pavement. And generally, for the by introducing the geosynthetics, we are able to separate the dissimilar materials in the pavement structure, and with that we are able to get the homogeneous. We'll put the homogeneous materials in the same layer, and this will be benefit for us to analyze the load or for us to find out the appropriate depths with the uniform features of the materials. It will be much easier for us to find out the accurate width that we have to use for the design of the pavement structure. And also, they will be worked as the reinforcement for the weak materials. Usually, the subgrade is considered as the weak materials. The reinforcement will prevent the transfer of both stress and shear force. And sometimes it will be worked as the filtration, so that the it will be utilized to separate the unpaved roads, and also try to separate the aggregates from base layers and also the subbase layers. And sometimes it can also be utilized, can benefit for the drainage system to help remove the waters from the pavement structure. And the water will move along the geogrids or geotextiles. That would be the mechanical method. It's widely applied for the pavement structure. The other method is called the chemical method, or the admixture stabilization. So in this method, we will use some stabilization agents like the Portland cement, lime flash, or the lime flash, bituminous, or some chemicals. For the Portland cement, it can apply for both coarse and plastic materials with a plasticity index less than 20. And for the lime flash and the lime flash, they are able to utilize for the plastic material soils, and which will have the PR less than 20. For bituminous, it's usually utilized for the coarse materials. For the chemicals, we will generally use them to improve the plastic soils. Basically, with the lime flash and the lime flash, they are able to reduce the moisture contents, increase the strength, and reduce the plasticity. And with that, it can have less deformation, and it can last for a longer time. And for the bituminous, it will be able to increase the strength, and also will be able to build in the waterproof materials, so that they will prevent the water entering the pavement structure. And for some chemicals, they are able to increase the strength, and as well as to reduce the the swelling potentials, so that the volume of the material will maintain constantly under different conditions. So here, so those would be the general method. First, for the first type of the method, will utilize the cement. As we just described, is able to improve the strength, compressibility, expansive characters, and also reduce their first susceptibility. And usually, what we do in the cement stabilization, we will add 2 to 8% cement. That will be the percentage in weight. We cannot introduce too much. If it's too much, then we will observe some cracks in the future. And I also have some limitations for utilizing the cement stabilization. If there are some appreciable sulfates or the organic materials in the soil, then we have to try to avoid the cement stabilization. Also, usually for this method, we need to compact them within 2 hours. So otherwise, it will get harder and not easy for you to work with. And it will be compacted to a minimum density of 95%. And this one is actually defined by the ASHTO M134. If you want to know more details, you can check the manual about it. And of course, once you conduct the cement stabilization, it's not done. There are also a lot of things that will affect the stabilization. The qualities, the quantities of the cement will affect the performance of the stabilization. The degree of the mixing, the time of curving, the dry density of compacted materials, and so on will all have impact to the performance. Usually, for the to add more, if you increase the percentage of the cement for the fine-grained soil, it was able to increase the plasticity index, but for the sand, this kind of improvement about the strength and the plasticity will depends on the void ratio of the compacted materials. So the trend is not clear. It actually should be specified based on the properties of the aggregates. And the second one is called the bituminous stabilization, and this is mainly applied for the granular materials, and it's not able for the fine-grained soil. And with this one, with bituminous, is able to reduce the water absorption of the soil. So with that, you are able to prevent the swelling potential of the aggregates, and you will provide both strength and cementation for the soil, so that it can support a larger load. And also it could be used as the membrane to control the moisture in the subgrade or the subbase layer, because the permeability of this layer is low, so it can prevent the water entering to the bottom or to the lower layers. And usually this one can be done in the field. It's mixed at low moisture contents, and with that it can maintain the best performance on the road. And these two figures shows how we can utilize the bituminous stabilization, as we have some machine to do the stabilization automatically. It's very fast and it's very convenient. The next one is the lime stabilization. The lime stabilization will only be applied for the fine-grained subgrade soil, or it will be applied for the coarse with certain fines. So basically, it will be utilized to minimize the impact of the fine particles. And to do that, usually we will add 1% lime by the weight for every 10% of the clay contents. But usually we will, if you have the anti-erosion work, you need to add more than 2% for the material. Another thing is like we cannot add too much in the clay of low plasticity index. And this, if you add too much, it will reduce the cohesion of the material. So you need to find out the trade-off and very tricky points about the amount of the lime should be added to the soil. And with this kind of stabilization, it will slow the strength gain with time. So so it can last for a longer time, and also the increasing the lime will decrease the soil density and increase the soil strength, and also change the plasticity index. And for the fly ash, if we include some fly ash to the lime, it can further increase the strength of the soil. So that's the stabilization with the lime, and also we can add the cement and the lime together, and with that it can change the surface chemicals of the clay materials, and this would be something very risky, because it might change the environmental or it has some negative impact to the environment. And the last one is about the stabilization with calcium chloride or the sodium chloride, and with these chemicals we can keep down the dust and retain the soil moisture and lower the freezing temperature of the water. This is very good for the pavement in the low temperature area, and it's able to it's mainly used for the for soil containing the clay particles. But this will also has a lot of problems for the environment, and it's also the traffic, as these chemicals will result in some corrosions to the cars, to the tire of the cars, and also it will result in some environmental problems, like they may contaminating the drinking waters. So we have to carefully think about utilizing the chemicals for the stabilization. So those are the general materials, the chemicals that we're going to use for the admixture stabilization. And here are the guidance for you to select the admixture for the stabilization. Depending on the, this actually depends on the plasticity index and the percentage of the particles passing through number 200 sieve. If it's more than 50%, we will have 3 different categories based on the plasticity index less than 10, between 10 and 20, and larger than 20. If it's less than 25%, which will majorly be some coarse materials, we will consider the plasticity index less than 10, less than 6, less than 10, and higher than 10. And with that, you can observe the materials that it could be used. In these figures, the black one represent the materials appropriate. The gray one means that is doubtful, and the white means that is not appropriate. So you can go to check, like, if the percentage passing number 200 sieve is more than 20%, and if the plasticity index is between 10 and 20, then probably you can use lime, or you can use some chemicals to do the stabilization. You can check the other materials in this. Also check the other materials in this graph. And there will be another way for you to determine what kind of materials admixture stabilizer. It could be applied for different type of the soils. This is it's still the same depending on the percentage passing through number 200 sieves, between 25 and 100, 35 and 100%, and less than 25%, and also based on the plasticity index. For example, for the plasticity index higher than 10, and the percentage passing through number 200 sieve between 35 and 100, then you can either use the cement or bituminous. And you can find out the other materials that you can use based on those two informations. So I think that will be all about the soil improvement and the stabilization. With that, we finished the introduction about the subgrade soils that could be used for the pavement design. And in the next lecture, we will introduce the drainage system, and we will see how we can design the drainage system, what's the most appropriate materials that we can use to improve the drainage of the pavement structure. I think that will be all today. Do you have any questions so far? Okay. If we don't have any questions, I think that will be all about the lecture today. And just feel free to send me email if you have any concern questions about the homework lab reports. I also received the email about the time of our final exam. So probably this weekend I will give you an update about the data and the time for both midterm and the final exam. And you will have, I think you will have plenty of the time for the preparation of these two exams. Okay, I think that will be all today. Thank you very much for your time. If you don't have any questions, I will close the meeting and I will see you next week.